Alright, today we're going to be talking about arithmetic sequences. An arithmetic sequence is a sequence whose consecutive terms have a common difference. So they change by the same amount each time. Okay, the common difference is represented by the number d, so whatever that is. So if it changes by 3 each time, then the d would equal 3. That would be your common difference. Okay. Example 1. Write the first 5 terms. Determine if it's arithmetic. So if so, give me the d. Okay, start with n equals 1. So I have my function an equals 5 plus 3n. Okay, so a1 equals 5 plus 3 times 1, so that's be 8. a2 equals 5 plus 3 times 2, so 5 plus 6 is 11. a3 equals 5 plus 3 times 3, so 9 plus 5 is 14. a4 equals 5 plus 3 times 4, so 12 plus 5 equals 17. And a5 is 5 plus 3 times 5, so 15 plus 5 is 20. Alright, if we look at these, the difference between each one, we went up by 3. Okay, so that means, yes, it's arithmetic because it goes up by the same difference each time. So your d is 3, okay, because it's going up by a positive 3. So let's look at example 2. I want the first 5 terms again, and I want to find the common difference, and then write what the function is. So write what an is. Okay, so this is the recursive thing that we did last week. So I've given the first term, it's 0.375. And they tell me that the next term is equal to your previous term plus 0.25. Okay, so a2 is equal to a1 plus 0.25. So 0.375 plus 0.25 equals 0.625. Okay, then a3 would equal a2 plus 0.25, so 0.625 plus 0.25 equals 0.875. And if we keep doing that, the next one will be 1.125, 1.375. Okay, the difference between each of these is plus 0.25. So that's your common difference. Okay, then to get your function, so remember last week when we were creating our equations, we took what our difference was, and that's what we multiplied by n. Okay, then I need to figure out what do I need to add to this when I plug in 1 to get my first term. So what plus 0.25 would equal 0.375. So 0.375 minus 0.25 equals 0.125. So that's what I would need to add. Okay, so here is our function for that example. Alright, part B is to find the sum of a finite arithmetic sequence. So to do that, we have the sum is equal to your n divided by 2, so that's how many terms, and then a1, so your first term plus an, your last term. So looks like example 3, I want to find the 150th partial sum of the arithmetic sequence. Okay, so they give me the sequence. It is 5, 16, 27, 38, 49. Okay, well, the common difference here, so, is 11. If we look, 5 plus 11, 16, 16 plus 11, 27, and so on. I need to figure out what the equation is first so I can find the 150th term so that I can use this and plug it in here. Okay, so S of 150 equals 150 divided by 2 times, well, I know my first term is 5, but I don't know my 150th term. That's what I need to find the equation for. So an equals 11n. Okay, then what do I need to do to add or subtract to get 5? Well, if I plug 1 in, I have 11. So to get to 5, I need to subtract 6. Okay, so to figure out what the 150th term is, so 11 times 150 minus 6. Okay, when I do that, I get, this is 1,644. So that's what I need to plug in here. Okay, now the sum of that is equal to 123,675. This is much easier to do than trying to add term 1 plus term 2 plus term 3 plus term 4 plus term 5, blah, 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 all the way to term 150. Okay, so this makes your finding the sum much simpler. Okay, the assignment for this is A4, page 659, numbers 12 through 15, 39 through 42, and 57 and 58. Sorry, running out of room. Please let me know if you have any questions, and good luck.